All right, so let's talk a little bit about what an electric field looks like. How can we actually represent the electric field on a piece of paper or on our screen here? So this is what you would call an electric field vector map. What I'm doing here is I'm visualizing an electric field at certain locations on a grid to see what the magnitude and direction of the electric field is at any given point. So I've sort of represented an electric field using this vector map here, and we're going to identify some of the features of these graphs. So remember that an electric field is a vector field, meaning that at every point in space, it can have a different magnitude and a different direction. And so we can see on this vector map here that there's a region in the middle where the vectors look roughly to be the same magnitude and generally all pointing to the right. If we move farther right, we can see that we have some of the center vectors look to be a little bit bigger in magnitude compared to the outer vectors, and you have a little bit of the vectors on the edges sort of pointing inwards a little bit. And this is even more dramatic if we look somewhere out here, where we can really see that down in the very bottom corner here, you've got a very small electric field at that location and a slightly bigger one up here, and they're all pointing sort of down and to the right. So this is a representation of the electric field that can be really useful to help you plot the electric field out to visualize what the electric field looks like in space.